So this is question 3 of the Natural Sciences Admissions Assessment specimen paper. And in this question we have a tube with sides of unit length, which means each side has length 1. And we want to find the length of the line which joins a vertex, so a corner, to the midpoint of one of the opposite faces, which is this dotted line here. So we're trying to find the length of this line. However, we can't just do that straight away. First of all, we need to try and find some other things. So the first thing we're going to do is try and find the diagonal of this base here, so across here. So can you think of a formula which could help us do this? So what we want to do is consider this pink triangle here, and the important thing to notice is that there is a right angle here, which is going to be hugely helpful because it means we can use Pythagoras' theorem, which is that the squares of each of the two sort of shorter sides of the triangle, so the 1 and the 1, is equal to the square of the hypotenuse, which is the length we're trying to find. So see if you can use Pythagoras' theorem to work out the length of this diagonal here. Okay, so what you should have done is squared this side, added them together, so that's 1 squared plus 1 squared, which is 2. And that's going to give you the square of this side. So this side itself is the square root of that, or the square root of 2. So now we have that this whole side is the square root of 2. So we consider another triangle, which is this one here. So this might be a bit hard to imagine to start with, but think of it as we're almost cutting a wedge out of the tube. We're coming diagonal here and along the base here and cutting out a slice like this. And you should be able to see that this is also a right angle triangle because we have something along the base which is horizontal and something completely vertical. So these two sides will form a right angled triangle. And we know that the base of this is going to be half the base of the whole thing, which is root 2. So we get a triangle which looks something like this. So this triangle here is exactly the same as this triangle here. So why don't you see if you can find x, which is the diagonal length we're looking for. So we can use Pythagoras again. So we have a squared, which is 1 squared, b squared, which is root 2 over 2 all squared, and this is equal to our unknown x all squared. So when we simplify this out, so we write out the squares explicitly, we get that x squared is equal to 3 over 2. And so x is equal to the square root of 3 over 2, and our answer is A.